Welcome. This is task 5.3, looking at something that is called a frustum, which is the bottom slice of a cone. So for example, looking at the one above, if you rotate it around the y-axis, so it's kind of coming around like this, right? You can imagine that that trapezoid, it becomes what's called a frustum, which is same thing as a cone, but it's missing the top. To find the volume of a frustum, you look at the difference of two cones. For example, the large cone, which we see here, would be this whole thing, and then we would subtract the small cone that is missing, and then we would end up with the volume of the frustum. And that's the approach that we'll use in these. I'm going to go to this one, number 3. It's apparently a flower vase, and it says to approximate it, and probably the best way to do this is to break it into sections, and since we're approximating, we're going to go with shapes that we know how to find the volume for, such as cones or cylinders. There could be other ways to do this using calculus, but we're not going to do that. So let's look at the sections I had. So the first frustum I had was, it looks like this. This is my first section, you can see in green. And the way to calculate that is to extend that so that you end up with a cylinder, and then you can take the difference between the volumes of the two cones. Actually, you end up with a cone, not a cylinder. And it's 1/3 pi r squared times the height. I think I had that here. 1/3 base times height. The base is actually a circle, so therefore a cone is 1/3 pi r squared times height. And so that was the first part. And then let's back this out. The second part you can see in yellow is just a cylinder, pi r squared times h. The third frustum that I created is this. Again, it's a cone with the upper part cut off. And if we extended that to a full cone, then we would be able to see it's 1/3 pi r squared, that's the base of 4, times the height of 6 is the large. And then the small part of that would actually be this. If we extend the lines here, this would be the cone that we're subtracting, and that is this one over here, which is 1/3 pi r squared, r being the radius of the base, which is 2, times the height, which is the height of the cone, which is 3. All right. Similar for the rest of these. The next one, the cylinder, pi r squared times h. The next one, we have a frustum, which we extend, which you can use different methods, but I went ahead and estimated what the height would be. You could figure it out using the scale. You could get a more accurate one, but I extended the segments until they intersected, and then I looked at the distance. Same thing, the volume is 1/3 pi r squared h, minus the small cone that's missing is 1/3 pi r squared h. And finally, there is another frustum right here that approximates the end of this. Again, this is the 1/3 pi r squared times h minus the cone that's missing, which is 1/3 pi r squared h. So it's always that. It's volume of cone and volume of the cylinder.